Welcome to NIOS live classes. Subject Science and Technology. Class 10th, book number 212, module number 2, Matter in our surroundings. Lesson number 3, Atoms and Molecules. Part 3. After study this lesson, learner will able to tell what is molecule and what is molecular mass. And also they can represent some molecules with the help of a formula. Also, after study this part, they can know what is molecular mass. And also can able to write chemical formula of compounds. .3 What is molecule? Dalton said that atoms joins together to form molecules which he called compound atoms. For example, you can see on the screen there is two compound atom. First is H2O, which is water, and second is methane, which is CH4. Today we know that a molecule is made of two or more atoms of the same or different elements arranged in a fixed way. These atoms are held together by chemical bonds. For example, two hydrogen atom, which is same elements, and one oxygen atom, a different element, bond together to form a single fixed water molecule, which is H2O. An atom is the smallest part of a substance, but usually cannot exist alone. On the other hand, can exist freely. There is a photo showing atoms and molecules. Atoms, example of atom is oxygen with 8 electrons, protons and neutrons. And on the other hand, a molecule which is H2O with 2 hydrogen and 1 oxygen atom. To describe a molecule, we use symbols and chemical formulas. For example, one oxygen molecule has 2 oxygen atoms. So, it is written as O2, and other elements that form diatomic molecules included 2 atoms. There is a figure showing how oxygen molecule made. The diatomic molecules are H2, which is hydrogen, N2, which is nitrogen, etc. Some elements are found as bigger molecules. For example, a phosphorus molecule has 4 atoms, so it is written as P4, and sulfur has molecules with 8 atoms and it is written as S8 at normal temperature and pressure. There is a figure showing on the screen. First is structure of phosphorus molecule and second is structure of sulfur molecule with 8 atoms and phosphorus with 4 atoms. A molecule that has 4 atoms is called a tetratomic molecule. And usually molecules that have more than 3 or 4 atoms are placed in a group of polyatomic molecules. A few years ago, a special form of carbon, which is called Buckminster fullerenes, was discovered. It has around 60 atoms, so its molecular formula is C60. Although you will study it in higher class. Molecules of compounds are made up of more than one type of an atom. For example, a water molecule has 2 hydrogen atoms and 1 oxygen atom, so it is written as H2O. A molecule of ammonia, NH3, has 1 nitrogen atom with 3 hydrogen atoms. For instance, you can look at the figure. A molecule of ethyl alcohol and it is written as C2H5OH. It has total 9 atoms, from which 2 is carbon atoms, 6 hydrogen atoms and 1 oxygen atoms. Molecules of water, ammonia and ethyl alcohol. There are visual representation on the screen. Now next subtopic is molecular mass. You have learned that a molecule can be shown using a formula which is called a molecular formula. This formula can belong to an element or a compound. The molecular formula of a compound is often used to find its molecular mass. If a substance is made of molecules like CO2, H2O or NH3, then calculating its molecular mass becomes easy. Molecular mass is found by adding the atomic masses of all the atoms present in that molecule. For example, we can understand it by a simple example of CO2. Let's find molecular mass of CO2. There is a equational representation of the molecular mass of carbon oxide. Carbon with 1 atom and oxygen with 2 atoms, and through combining them we get 44.0 units, which is our molecular mass of carbon or carbon oxide. Similarly, if we obtain molecular mass of NH3, which is ammonia, so we get 1 nitrogen atom with 3 hydrogen atom, so it will be written as NH3, and through combining them we get 17.24 unit, which is the molecular mass of ammonia. For substances that do not exist as molecules, we use the term formula mass instead of molecular mass. For example, sodium chloride is an ionic compound, not a molecular one. So, for NaCl, we calculate the formula mass in the same way as we calculate molecular mass, by adding the atomic mass of the atoms present in its formula. There is a equational representation of the formula mass, how we apply it with the atomic numbers and atomic masses. For example, we have get the sodium chloride formula. Let's take a short break. Welcome back to our classes. Now we are going to look and learn what is mole concept. A mole is a counting unit used in chemistry. Scientists use moles because atoms are very tiny and cannot be counted one by one. Like in general, a dozen means 12 items, same as 1 mole equals to 6.02 into 1023 particles of atoms, molecules or ions. In short, we can say the mole concept helps us count atoms and molecules easily in chemical reactions. Chemical reaction example: when two substances mix, a new substance is formed. For example, H2O, here two molecules of hydrogen reacts with one molecule of oxygen to form two molecules of water. Atoms and molecules are very tiny. We cannot count them one by one and we cannot see through our naked eye. So that's why scientists use this special counting unit which we call mole. And we know that mole is a unit used to count atoms and molecules, and it is written as MOL. Here is a scientific explanation of mole. A mole is the amount of substance that contains as many elementary entities, which is atoms, molecules, formula unit or other fundamental particles, as there are atoms in exactly 0.012 kg of carbon-12 isotopes. One mole is equals to 6.02 into 10 is to 23 particles. This number is called Avogadro's number. When this number is divided by mole, it becomes a constant and is known as Avogadro's constant, denoted by symbol Na equals to 6.02 into 10 is to 23 with mole 1. We have seen that atomic mass of carbon is 12 units and atomic mass of helium is 4 units. So this means One carbon atom is 3 times heavier than one helium atom, so the same number of carbon atoms will always be 3 times heavier than helium atoms. Since Avogadro's number with carbon atom weight 12 gram, so helium atom's Avogadro's number will weight 4 gram, and this amount is called 1 mole. In the same way, we can find the mass of 1 mole of any element. Now we are going to learn about molar mass. The mass of 1 mole of a substance is called its molar mass, and that substance can be an element or a compound. One mole of oxygen atoms means 6.02 into 10⁻23 oxygen atoms, and it weighs 16 gram. And 1 mole of oxygen molecule O2 means 6.02 and 10⁻23 molecules, and its weight will be 32 gram. There is a picture showing 1 mole of oxygen atoms and 1 mole of oxygen molecules. If it is not clear whether we mean atoms or molecules, we take the natural form of the substance. Oxygen exists as O2, so 1 mole of oxygen means 1 mole of oxygen molecule. One mole of oxygen is equals to 1 mole of oxygen, which is O2 molecules. For compounds, the same rule applies. For example, 1 mole of water is weighed 18 gram. In numbers, the molar mass of a substance is equal to its atomic or molecular mass in grams. Molar mass is always written in gram by mole. For example, molar mass of nitrogen N2 is 28 gram by mole, and molar mass of chlorine, which is Cl2, will be written as 71 gram by mole. There is a table showing the molecular and molar masses of some formulas. Let's take a short break. Back to our classes. Now let's look at some chemical formula of compounds. Chemical formula means writing a short way to show which elements make a compound and how many atoms of each element it has. We use element symbols and small numbers to write formulas. For example, H2O means water has 2 hydrogen atoms and 1 oxygen atom. Chemical formulas help us understand what a compound is made up of. But what is compound? A compound is made up of two or more elements, and these elements combine in a fixed mass ratio. This combination follows the law of constant proportion. And the elements are represented by their symbols like H for hydrogen, Na for sodium, etc. The compound is written using a chemical formula, and the formula shows us which elements are present and number of atoms of each element. The number of atoms is written as a small number at the bottom right of the symbol. For example, in water H2O, the subscript 2 shows 2 hydrogen atoms and no subscript on oxygen means there is 1 oxygen atom. We have completed our part 3 of atoms and molecule. Thank you for watching.